In this lecture, we'll be taking a closer look at the earliest fossilized evidence of genus Homo. Please take a closer look at this slide. It provides you with a breakdown of the physical traits that paleoprimatologists and paleoanthropologists assign to Homo habilis. This is the earliest fossilized evidence categorized as genus Homo. It was recovered from East Africa by members of the Leakey family, in this case, Louis Leakey. Louis Leakey named this type fossil that we'll be taking a closer look at in 1964 as genus Homo, or Homo habilis, meaning handyman. Since the initial discovery of this form, habilis remains have been recovered not only from Olduvai Gorge, where Louis Leakey worked, but also Omo in southwestern Ethiopia, Kubifora in Kenya, and Hedar. Since its discovery in the mid-1960s, this particular fossil form in the evidential population that we now have has created a great deal of controversy among anthropologists. The greatest element of this controversy is how this particular form is to be taxonomically classified. Should this be recognized as an Australopithecine or truly a member of genus Homo? Homo habilis characteristics include the following. We recognize heights, at least for the female material that has been recovered, to average at or around 3 feet in stature. Weights are and have been projected for both males and females. You can see those listed there on this slide. Brain size is much larger than what we've seen up to this point. In this case, a composite average of approximately 612 cubic centimeters. The range in this case is between 509 and 674 cc's. When we look at the cranium qualitatively, we can start to interpret some of its shape. We still see that mid to lower facial prognathism or projection. We see the presence of a brow ridge, a foreshortening in the palate, little to no sagittal cresting, and a rounded mandibular base. As we take a closer look at the dentition itself, these are some of the characteristics that we assign to Homo habilis. We recognize a narrower, lower grinding expression to teeth, or the occlusal surfaces of those lower teeth. And in a variant of genus Homo, Homo rudolfensis, who again, as a type fossil, is a bit controversial, and we'll address this in the next slide, we see a single root to the lower premolars. Now the postcranial anatomy. Postcranial limbs, again, longer arms and shorter legs than what we see today in the variability of living humans, or Homo sapiens sapiens. And we see the retainance of a grasping foot, in this case a first digit on the feet that would be able to grasp. As paleoanthropologists have reconstructed the cranial and postcranial anatomy of the habilis group and the rudolfensis group, we as a whole recognize locomotion as being most likely bipedalism, in this case habitual bipedalism. The dates associated with the initial discovery of this form fall between 3 and 2 million years ago. However, as continued discoveries have occurred, this particular date range has been extended to approximately 1.6 million years ago. Here is a graphic comparing habilis, in this case on the right, to rudolfensis on the left. As you can see, we may be dealing with enough biodiversity in the crania of these two forms to be able to talk about separate species. However, this is still very controversial. As you examine and compare these two photographs, there are some similarities that you will immediately be aware of. To review, again, when you look at these forms, you're dealing with individuals who have little to no expression of a sagittal keel or sagittal crest. Additionally, we see a reduction in that supraorbital eminence, or the bony brow ridge that we have recognized in other forms that, in a sense, date to earlier deposits within East and South Africa. Additionally, as you look at these two crania, you begin to see the reduction in that mid and lower face, in this case, only mild prognathism or projection. And what you can't see here, but what I can tell you is present, is the expression of a rounded mandibular base and, correspondingly, a small degree of flexure associated with the base of the skull. Taken as a whole, these are human-like traits. These are also traits associated with habitual bipeds that we will continue to look at in the remaining portions of this course and in the remaining deposits within earthly geology. Homo erectus represents one of those all-important future forms that, in some way, shape, or form, must be relatable to what we have in our habilis and rudolfensis groups. Take a moment here to take a look at the regional diversity within this population and some of the common patterns associated with physical traits such as height, weight, brain size, the qualitative nature of the cranium, its dentition, and the postcranial anatomy. What really becomes important when we look at this next stage within the populational development of genus Homo, in this case Homo erectus, is that we have a fossil which covers both a large time period and a large geography. This expanse of both time and space tells us that we have variability within a very large population of humans. This variability would be expressed on a regional level. Some of the variability within the erectus material is so extreme that paleoanthropologists have begun to consider additional species or even subspecies. We looked at Homo ergaster in our last lecture together. This material, drawn from Lake Turkana in Africa, may in fact be a separate species of genus Homo, or it could be classified as a subspecies of erectus. Whatever the case may be, Homo erectus, the material that we associate with this population of true humans, is quite unique for a variety of reasons. Let me focus in on a couple points from the slide you're currently examining. When we look at the cranium of Homo erectus, it seems to have retained a number of very primitive qualities or traits. One of those traits is its low, long-vaulted brain case, sometimes referred to as platycephalic in nature. It is wider at the base, expresses large brow ridges, and has some sagittal keeling, almost a crest, forming along that sagittal line of the top of the skull. However, when we take a look at the postcranial anatomy, the erectus material as a whole, as a population, or a sample from the past, fits well within the biodiversity of living humans today, though it wouldn't be common. It wouldn't be the mean expression of our height, of our arm length, of our stature. What this means for us is that the Erectus material across many regions and in association with tools, which we'll talk about in just a moment, represents another example of mosaic evolution. However, in this case, it is a mosaic expression of a human model, one that spans at least three regions in the Old World, Africa, Asia, and Europe, and a large timeline, anywhere between 2 million rather, and 27,000 years. Lastly, as we have more and more evidence of the neurocranium as it relates to these fossilized forms, in this case a casting of the cortical surface of the erectus brain, we realize that the architecture of the brain is very unique and is human-like. One particular element of the erectus brain, in this case the Broca's area of the frontal lobe, is well defined and is human in its overall size, orientation, and expression. What this means for us is that the erectus populations probably had enough abstract thought, or expressed a level of abstract thought that would have allowed them to have a complex system of communication approaching the level of language. When paired with a standardized tool type, a type that is standard across all three of these regions and expressed in nearly the same way with the same material, and I'm speaking of the Acheulean hand axe tradition, we most likely have an individual that could produce a language similar to our own. Take a moment to examine this next slide. In it, you will note that we are looking at the occipital region, or the back of the skull, for four different forms, fossilized forms in this case, three of which are erectus. These particular erectus expressions fall within the variability that we saw summarized for us in the last slide. You will note, however, that in this occipital region, there are some expressions of variability. So we know that all three of these expressions of erectus are platycephalic in nature, that there is some sagittal keeling, and we can see that in relation to the Neanderthal material from La Chapelle-aux-Saints in France. However, we do see some slight amounts of variation in these three typical erectus expressions. Two from Indonesia, Java, and one from Zhoukoudian, or the Zhoukoudian cave site in what is today modern China. Paleoanthropologists today are struggling over how much of this variability connotes a subspecies, or how much of this variability is explainable through isolation, genetic isolation in this case. And as you can see, there's a real difference between these three examples of erectus and what we have in archaic and anatomically modern human populations in Europe. We'll cover archaic human populations and anatomically modern humans in our next lecture. Let's take one more look at erectus. Here is that typical erectus skull and a forensic reconstruction of what a typical erectus may have looked like. As I said earlier, the erectus cranium is very different from what we see in terms of human populations today and human populations that were thriving as we approach the late Ice Age, or the latter portion of the Pleistocene epoch. However, the postcranial anatomy, which is not reconstructed for you here but is addressed in your course textbook, is very human-like, and as I mentioned earlier, does fit within the overall biological variability of our living species today. Take a moment here to review the geography of what we have in the Old World and the geography of Erectus sites. Erectus, again, is important because it is the first fossilized form that we're examining as part of the curriculum of this class to appear outside of Africa. And it is a fossilized form which spans a significant amount of time. Finally, take a look at this slide. Compare the dates, the distribution, the geographic distribution, the important sites, of course, within that distribution, and the cranial capacity of living humans, Homo sapiens sapiens, to archaic forms, to erectus, and to the common chimpanzee that we find in Central Africa today. Ask yourself, what might account for these similarities and these pretty significant differences?